Hello and welcome to helpyourmath.com. In this video, we're going to look at solving trigonometric equations. So, first, what is the goal when solving trigonometric equations? And you might be thinking, well, duh, you want to get x by itself. And actually, no, we actually don't. What we actually want to do is we want to isolate the trigonometric function. So our goal is to isolate the trigonometric function. A little bit different. And the reason we want to do this and we don't want to actually get x by itself is because that would be using inverse trig, and that actually doesn't apply when we're solving these types of trigonometric equations. Yikes, right? Okay. How many solutions do you have when you solve a trigonometric equation? What do you think? 1, 2, 3, 4? If you guessed infinitely many, you would be correct. So technically every trigonometric equation has infinitely many solutions. However, usually what happens is we limit the range of what we want our solutions to be. So usually you'll see it's going to say, state all the solutions between 0 and 2 pi. It's not going to have you list all of them. However, if you aren't given any restrictions on how to express your variable, what we would say is you would say whatever the piece is, and usually when we are solving these, we express our solutions in radians. So you would have your radians, whatever they may be, and then you say plus 2 times n times pi, because what this, where n represents an integer, so we say n is an integer, because if one solution, let's say, is pi over 2, then if you do a full circle around and you're at 5 pi over 2, 7 pi over 2, that would be the same, that would also give you that same solution because those are coterminal angles. So because every angle has infinitely many angles that are coterminal to it, there's infinitely many solutions with these trigonometric equations. So if you're asked to express it, you would just take what the solution is and add 2n times pi to it. That's just going to create all the coterminal angles. Let's look at some examples. So in our first example, it says solve the following equation. And you'll notice it doesn't give any sort of range to express the answer in. So we're looking for all the possible solutions. The first thing we want to do is get sine of x by itself. It's being multiplied by 2, so I'm going to divide both sides by 2. And that's going to leave me with sine of x is equal to 1/2. Now just think back to your unit circle and think about when is sine of x equal to 1/2. So with any sort of solution we get here, or with any sort of equation we have, there should be 2 solutions between 0 and 2 pi. So one time when x is equal to 1/2 is at pi over 6 or 30 degrees, but again, we usually use radians. So one is pi over 6, and then we have to say, wait, but it's not just pi over 6, it's any angle that's coterminal to pi over 6, so we say plus 2n pi. But x could also be, so where else is sine positive? In which other quadrant? In quadrant 2. So if we think about quadrant 2, now pi over 6 becomes our reference angle. So this is the angle we would want here. This is now x, and this would be x hat. This would be pi, and this is our reference angle is pi over 6. So what would the rest of that angle be to get to pi? And that would be 5 pi over 6. If you don't like my floofy math, what I just did there was I said the angle has to be pi minus pi over 6, and then you can find a common denominator, and you're going to get 5 pi over 6. But we need all the angles that are coterminal to 5 pi over 6, so we need to add on 2 times n times pi. Okay, in our next example, now we have the interval for the possible solutions. So now we're only looking at the solutions between 0 and 2 pi. Keep in mind that 0 to 2 pi does make a complete circle. So we're talking about the two, basically think about the 2 quadrants in which we're dealing with something negative or positive. Okay, so our first goal, get cosine of x by itself. So I'm going to add 1 to both sides. We get the square root of 2 times cosine of x is equal to 1. Divide both sides by the square root of 2. And now we get cosine of x is equal to 1 over the square root of 2. Let's rationalize that denominator. There we go. And we have root 2 over 2. Okay, so where is cosine equal to root 2 over 2? And this is positive root 2 over 2. So one possibility is that x is equal to pi over 4, right? Because cosine of pi over 4 is root 2 over 2. Or where else in that unit circle is cosine positive? It's positive in quadrant number 4. So if we go down to quadrant 4, here's the angle we're looking for, x. Here's our reference angle, x hat, which is going to be pi over 4. Now we started at 0, and the complete circle is 2 pi, and the last missing piece is pi over 4. So what's the rest of it? That would be 2 pi minus pi over 4. 2 pi is equivalent to 8 pi over 4, so we would have 7 pi over 4. And these would be the only two possible solutions within this given interval. So you want to make sure that that interval is given. Otherwise, you have to go back and write it like this with that plus 2 times n times pi attached to it. These have been some examples of solving trigonometric equations. Thank you for stopping by.